Teaching mathematics, well, doesn't start with a worksheet. It starts with understanding what students are actually being asked to do, and what teachers must intentionally design for them to be able to do it. State content standards matter because they define the learning destination. But a standard is not a lesson, and it is not instruction. It is a claim about the kind of thinking students should be able to do independently. Too often, standards are treated as compliance documents rather than analytic tools. Unless teachers learn how to study standards the same way they study tasks or assessments, instruction drifts toward coverage instead of learning. This is why standards work is not about reading standards. It is about analyzing them. Consider a common 6th to 12th grade standard related to linear relationships. The language might ask students to represent a linear relationship, interpret slope and intercepts in context, or model a situation with a linear equation. On the surface, this looks like graphing or writing equations. But the standard is not actually about drawing a line. It is about interpreting a situation, identifying a relationship, choosing a representation, and explaining what that representation means. Backward design gives structure to that analysis. You start with the end in mind, but the real work is not writing objectives. The real work is translating a standard into the thinking demands that instruction must develop. That translation requires teachers to slow down and ask what the standard actually requires students to do with their thinking, what decisions students must make independently, what representations or justifications are implied, and what it would look like if a student truly understood the idea. In practice, backward design means teachers must be able to say, if a student can do this without prompts, the standard has been met. For the linear relationship example, that this might include explaining what a slope represents in a real situation, choosing whether a table, graph, or equation best fits the context, and justifying how the model matches the situation. A correct graph alone would not be sufficient evidence of understanding. When teachers skip this analytic step, instruction defaults to procedures, plot points, find slope, write an equation, even when the standard clearly demands reasoning and interpretation. Once the thinking demanded by the standard is clear, the next question is not what activity to use, but what kind of work students must engage in to develop that thinking. This is where task cognitive demand becomes essential. Many standards in grades 6 through 12 require students to analyze situations, model relationships, connect representations, and justify conclusions. That level of thinking will not develop through low-demand practice, even if the topic matches the standard. Returning to the linear example, students may be given a context like a cell phone plan or a savings account. A low-demand task might tell students exactly which equation to write and which points to plot. A high-demand task would require students to decide what quantities matter, determine whether the relationship is linear, choose how to represent it, and explain what the slope and intercept mean in context. Cognitive demand, however, does not live only in the task itself. It also lives in how the task is implemented. A high-level modeling task can be reduced to a step-by-step procedure if the teacher tells students what to do at each point. Conversely, a moderately demanding task can be elevated when teachers press for reasoning, ask students to explain why a representation fits, allow multiple strategies, and compare approaches publicly. This means teachers must analyze themselves as part of planning. When working from a standard, teachers need to ask where students will need to decide rather than follow, where confusion should be productive rather than immediately resolved, and which teacher moves will preserve the thinking rather than shut it down. In the linear example, that might mean resisting the urge to immediately show the equation, and instead asking students how they know the relationship is linear, and what evidence supports their claim. This is where respectful teacher-student interactions stop being separate from instruction and become necessary for it to work. Self-determination theory explains why students stay engaged in demanding cognitive work. Students are more likely to persist when they experience autonomy, competence, and relatedness. These are not personality traits or classroom climate preferences. They are instructional conditions that teachers design. Autonomy matters because standards expect students to make decisions independently. In the linear modeling example, Autonomy shows up when students can choose whether to represent the situation with a table, graph, or equation, and then justify that choice. If students never practice making those decisions during instruction, they will not be able to do so independently. Competence matters because students need clarity about what quality work looks like. This is where backward design connects directly to respectful instruction. Clear success criteria help students understand what it means to interpret slope correctly or explain an intercept in context. Feedback tied to those criteria supports improvement without rescuing and keeps the focus on reasoning rather than correctness alone. Relatedness matters because high-level thinking requires risk. Students must be willing to share incomplete ideas, revise models, and explain reasoning that may not be fully formed. When teachers listen carefully, revoice to clarify rather than correct, and treat student ideas as worth examining, students are more willing to engage in the reasoning the standard demands. Respectful interactions allow teachers to maintain rigor without shutting students down. When backward design, task cognitive demand, and self-determination theory are used together, they form a coherent professional framework. Backward design clarifies what thinking must be developed. Task cognitive demand protects the level of thinking during instruction. Self-determination theory explains how classroom interactions sustain that thinking over time. This is also where opportunity becomes visible in practice. Opportunity is not that a standard exists. Opportunity is whether students consistently experience instruction that develops the thinking the standard requires, whether they are given time and space to reason, and whether classroom interactions make participation safe and expected. In the linear relationship example, opportunity means students repeatedly encounter situations where they interpret, model, and explain relationships, not just plot lines. It means they are expected to reason publicly and are supported to do so. This brings the work back to the teacher. Just as with assessments, teachers must do the analytic work themselves. They must study standards as learners would encounter them, identify the invisible thinking embedded in the language, and design instruction that makes that thinking learnable. This is not optional. It is core professional practice. The question shifts. Not did I teach the standard? But what thinking does this standard demand? And how am I intentionally building that thinking over time? That shift defines instructional practice, and it is the foundation for designing instruction that is coherent, rigorous, and supportive of student opportunity.